Today we'll discuss two different topics. One is virtual destructors. Second is RTTI. That stands for runtime type information. Some part of it we have already done, RTT. So let's begin with virtual destructor first of all. Let us have a base class with a public there is a constructor and let there be a destructor. From this we will create a derived class. Its constructor and its destructor. So this is what we have been doing earlier also, but what is the difference here? Have a look. I'm creating a base class pointer. Rather, I'm creating two base class pointers. And to pointer B1, I'm assigning a new base object. And to pointer B2, I'm assigning a new derived pointer. Okay, even before that, if I write pointer B1 is equal to we have object of a derived, we are giving its address here, object of D. Let these two not be there. Suppose this is the case. And after that, we are deleting pointer B1. And suppose we have done some work here. And after that, we are deleting the base pointer. See what will happen. Oh, there is some sort of exception. Let me check it again. Some other problem is there. We have base, we have derived from public base. Everything is fine. There should not be any problem. There shouldn't be any problem here. Let's try it again. What's gone wrong? It was working perfectly fine till now. Okay, I don't know what's the problem. What will be the output of this? Anybody? We try to run it one step at a time.
कंस्ट्रक्टर और डिस्ट्रक्टर रन होगा derived का.
Okay. We are doing it through pointer of base. Okay. This is
Yes,
important.
sir.
This is important. Oh, it's behaving strangely. Let me run it again. Just a minute. Let's start do it again. It's running, but why is it triggering a breakpoint here? Okay, let's run it one step at a time, see what will happen. So because of this, it will call a base class constructor and a derived class constructor. It is happening because of this. Okay, so when we are deleting it, let me check if it is working. When we are deleting, it is calling base class destructor. It is not calling derived class destructor.
Yes, sir.
The fault lies here. If we make it a virtual destructor, then it will run properly. I don't know what kind of problem is it causing. We have a class base is there, destructor is there, derived is there. Can anybody find any fault in it? I don't see any. I don't see any fault here. I don't know what kind of problem is it causing. Let's try it
Sir,
again. Yeah.
delete जो है वो तब नहीं यूज करते जब मेमोरी एलोकेट हो गई होती है.
Really sorry for
या
that.
फिर
I'm so sorry. That was the problem. Okay, let's do it again. अभी क्या है? It is simply constructor and destructor in both of these. So when we are executing it, this is the output. Let me show you again. It should be like this. अभी ठीक है ये. हमने new नहीं use किया था. That's why it is causing problem. Okay, what we have done, we have a base class pointer to which we are assigning address of object of derived through new operator, and then we'll delete it. Look here, the constructor and destructor both are normal. I mean, destructor is normal.
Yes,
so when we run it, the problem is it will call base class constructor, derived class constructor, and base class destructor. It is not calling derived class destructor. It means derived class object will not be deleted. So we need to declare the base class destructor as a virtual destructor. A constructor can never be virtual, but a destructor can be. So what will happen in this case? Once we have declared the base class destructor as virtual, now you can see it is calling derived class destructor as well. Is this thing clear?
सर एक बार फिर से बता दोगे?
I tell you, if the base class destructor is normal destructor, and to a base class pointer, you are assigning object of derived class, right? You are assigning to a pointer address of object of derived class through new operator, and then we are
Yes, sir.
deleting it. Fine. What will happen in this
Yes,
case?
sir.
What will happen in this case now? It will call base class constructor because of this derived. It will call derived class constructor since we are creating an object of derived. But when it is destroyed, then it will call base class destructor only because you are using this method of allocating memory. You are using new function operator to allocate address of the new object that has been created in memory. So what is happening? It is missing the derived class destructor. It means the object of derived class is not deleted. So the alternative here is to declare this as a virtual destructor in base class. So once you will do
Okay, sir.
this, then it will call the derived class destructor as well. So it is here. Is this thing clear?
Yes, sir.
Yes, sir.
Okay. Now moving to the second part of it, runtime type information. Let me now have two different so first pointer is containing address of object of base, and second pointer is containing address of object of derived.
Right.
Now, what will be the type? Like here I am writing cout type ID. This we had discussed when we had discussed typecasting also, type ID, right? So runtime type information is what is the type of some object or some identifier during execution of the program. Like here, if I want to know what is the type of pointer B1 and then its name, what is the type? Anybody? What's the type of pointer B1?
So base class.
Base pointer.
It is a base class pointer. Okay.
Yes.
And what's the type of PTR B2? Second?
Drive. So
Base
base
class
का वो भी.
Base class pointer.
This is something very important. We are using pointer variables right now, and their types are base pointers only. Have a look here. Have a look here. Both of them are base pointers basically. Oh, still some error. What's happening today?
सर वहाँ PTR B1 को भी ड्राइव दिया हुआ है एक ही पॉइंटर को सर.
Okay, okay. नहीं problem कुछ और थी. अभी is it fine? Okay, fine. Look here. It is base class pointer, base class pointer. Both of these are basically base class pointers. But when we write here a pointer, it means now they are pointing to what kind of data? PTR B1 is pointing to
base class.
PTR B2 is pointing to
Base as well.
derived. PTR B2 is
Derived
pointing
class.
to derived class. Now it will change. As you can see here, it is first one is pointing to base class, second one is pointing to derived class. So during the execution of program, if you want to know what is the type of some identifier, then you can use this method. This is one method. Type ID, within brackets you will provide the identifier or object or whatever it is, and then through dot operator name you can get its name. Is this thing clear?
Yes,
It's
sir.
Yes, sir.
something simple. Okay. This is about runtime type information. Now let us consider an example. Suppose we have a shape, right? And from this, suppose we are deriving an ellipse, and from ellipse we are deriving a circle. Similarly, from this we are deriving a rectangle, and from this we are deriving a square. Let me write all these names here once. So we have shape, we have ellipse, we have circle, and we have rectangle, and we have square. So we had discussed this problem earlier also when we were discussing that dynamic polymorphism, that all these four are of type shape. All these four are of type shape. So shape is basically now a what kind of class?
Base class.
What kind of base class?
Abstract base class.
Right, absolutely right. So we assume that shape is an abstract base class. So here circle, because shape in itself means nothing, right? We have to make some concrete classes out of it. Otherwise, it doesn't convey any meaning. So some different day today, I think. Okay, so the hierarchy is something like this. Okay, so shape is an abstract base class because we cannot create objects of shape. Shape in itself means nothing, right? So we'll create two classes from it, ellipse and rectangle. Using ellipse, we'll create a circle class, and using rectangle, we'll create a square class. And then let us see how does it work. So let me create all these classes once. Class shape, protected state. We'll be discussing many things which we had covered earlier also. Count. Shape, count plus plus, void draw. Since it cannot have a draw function or implementation of draw function, we'll set it equal to 0. And then shape, count minus minus. Just check it. Is it clear?
Yes, sir.
This is a, what we call it?
Yes, sir.
What we call this?
Pure virtual function.
It's a pure virtual function.
Pure
When a
virtual.
virtual function is equated to 0, it becomes a pure virtual function. It means the class will become an abstract base class. Then you will not be able to create objects of this base class. It can be used only for the purpose of inheritance. You clear it?
Yes, sir.
Okay. Now let me define count here so that it is automatically initialized to 0. The next class is ellipse, derived from shape, let it have its own function, its own data member count, public ellipse plus plus, void draw. Simply write here cout ellipse, then In the destructor, we will decrement count. Here we'll write int ellipse count. So we have defined its count member. Okay, let us have one more function here. Let it be void static void display count. What it will do, it will display the count of, I'm calling it for shape. It will tell us how many shapes have been created. Similarly, let's have a function, same kind of function for ellipse as well. It will tell us how many ellipses have been created. And let us use it and extend it to class circle. Now circle is derived from ellipse. We'll have a static count, which will keep count of how many circles we have created. Process is same. In the constructor, we will increment the counter, and in destructor, we will decrement the counter. So we'll have the count of total number of active objects of each class type. So similarly, let us define its count. Okay, now using these, let us create a rectangle and square class as well. I'm copy pasting it, will save some time. So first is rectangle. Here it will be rectangle. Here we will have square. Square is derived from rectangle class. Square. Make all the changes. I'll share the code with you, don't worry. Square. Here. Is this thing clear? The classes we have created? We have created
Yes,
a
sir.
base class.
Yes, sir.
Every class has its own count also. Okay, every class has its own count as well. Okay, we had discussed vectors last time.
Yes, sir.
Yes, sir.
So we'll be using vectors also. Include vector. Okay. Vector shape pointer shapes. Okay.
Yes, sir.
Okay. Why the error? It has to be like this, perhaps. Why it's saying undefined? It shouldn't be vector dot h, I suppose. Okay, fine, it's working. Okay, now what we'll do, some number will randomly generate a number. So let's include time h as well. Say maximum 15. For integer I is equal to 0, I less than some number, I plus plus, and let us generate one more random number. How many shapes, how many concrete shapes do we have? We have 4 concrete shapes. These
sir.
4 shapes are concrete shapes, right? Shape is abstract, all 4 are concrete. So let's do shape count is equal to random, or shape index is equal to random modulus 4. Okay. Switch shape index. So if it is 0, we'll create ellipse. If it is 1, we will create circle. If it is 2, we will create rectangle, and if it is 3, we will create square. Is this thing clear? First of all, randomly we are
Yes, sir.
generating how many total shapes should be there. Or let us fix it.
Yes,
Let
sir.
us fix it. Let us fix it to 15. No problem. Let's remove this. So in all, we will be generating 15 different shapes, and it will depend randomly. It will be decided that which shape is to be generated. Since we are randomizing it to up to 4, so it will generate values from 0 to 3. Depending on the value,
Yes,
we
sir.
will create it. What we'll do now, shapes dot push back, like right now it is, we are to create an ellipse. Just a minute, it should be I. We are to create an ellipse, new ellipse, right? Similarly here, shapes dot pushback, new circle. Similarly here, shapes dot pushback, new rectangle, and lastly we have shapes dot pushback, new square. Now, since it's been randomly generated, we don't know how many of ellipse or circle or rectangle or square have been generated. We have no idea. Now let us check how many of these have been generated. Okay, let's do it again. For integer I is equal to 0, We know that total 15 shapes are there, but we don't know which one of these were there. So if dynamic, I hope you remember dynamic cast operator. First shape is
Ellipse.
ellipse
Ellipse.
pointer. Shapes I. Then what should we do?
Count function कॉल करेंगे.
कौन सा फंक्शन कॉल करेंगे?
जो ellipse का है. जो ellipse का है वो static function.
Now we'll write हमने जो कॉल किया ये फंक्शन भी स्टैटिक है, डिस्प्ले, राइट? सो ड्रॉ फंक्शन को भी लेट्स मेक इट स्टैटिक. एवरीवेयर लेट्स मेक इट स्टैटिक. So that we may be able to know कि draw क्या हुआ. Okay, it is ellipse, draw ellipse. If dynamic cast circle pointer shapes I, then circle, draw circle. Similarly for if it is a rectangle, we will call draw rectangle. If it is for square, then we'll call draw square. Okay. So this is how it will go. There are errors. Okay, static के कारण प्रॉब्लम आ रही है. वर्चुअल स्टैटिक तो नहीं होगा. count happy got a display count. Okay. Okay, let me just check it. Fine. After that, let us call all these functions. I'll explain it in a minute. Okay, let me explain it once again. So I think this part is clear.